Hello, we will learn one more derivation rule, which is called the general power rule. So as you might recall, a couple of videos ago we learned about the power rule, but the general power rule is a little bit more, I would say, maybe useful, generalized. So the general power rule is as follows. So the derivative of some function with respect to x, so h of x raised to n, is just equal to n times that function, but now raised to n minus 1, times the derivative of that function with respect to x. So maybe that's a little bit confusing, but let's work an example out. So let's say that we want to get x to the fourth, but instead of just getting 4x cubed like we would do with the general power rule, with the power rule, now let's define h of x to be x squared. And we have this function that we want to get the derivative of h of x squared. So as you might know, x squared is just x to the fourth. And so we will use the general power rule, and let's work this out. So we basically do the power rule like we did before. So we bring the exponent down as our coefficient, then we multiply it times h of x, which we define to be x squared, and now to our exponent we subtract 1 from it, so that's just to the 1. But now we will multiply it times the derivative of h of x, and so we know that the derivative of h of x is 2x, right? And so now we just have 2x squared times 2x, and this is just equal to 4x cubed, which is exactly the same thing that we got with the rule that we knew already. But well, it's really no fun to do it with things that we already know how to solve. So let's look at another example. Let's say that we had f of x is equal to 2x to the fourth minus x cubed. And so I would like to do this problem in two ways, using the chain rule and using the general power rule as so that it works as an exercise for both rules that we have barely gotten introduced to. And so using the chain rule, well, so by having f of x is equal to 2x to the fourth minus x cubed, well, as you might recall, the chain rule said the following, that dy over dx is just equal to dy over du times du over dx. And so this looks very similar to a problem that we already did. We could just define u to be 2x to the fourth minus x, and so y is just equal to u cubed. And so dy over du, well, that's just 3u squared, and du dx, well, that's just 8x cubed minus 1. And so as you might recall, we just need to multiply these two. And so that's 8x cubed minus 1 times 3u squared. But we know that u is actually 2x to the fourth minus x. And so we have figured out our derivative. And let's see if we get the same thing using the general power rule. So the general power rule, Well, we have y is equal to 2x to the fourth minus x cubed. And so remember that first it looks just like the power rule, so we bring down our coefficient, and then here we have 2x to the fourth minus x, and we decrease the we bring down the exponent as the coefficient, I'm sorry, and then we decrease the exponent by 1, and then we just multiply this times the derivative of our h of x, which is the function that is being raised to a given exponent. And so in this case it's 8x cubed minus 1. And so this is the solution based on our general power rule. dy over dx is equal to this. Let's see if we got the same thing. Well, we got 8x cubed minus 1, 8x cubed minus 1 times 3 times 2x to the fourth minus x squared times 3 to the 2x, times 2x to the fourth minus x squared. We got exactly the same thing using these two new rules that we have just been introduced by. And actually you could derive the general power rule using the U substitution, or as we call it, the chain rule. And let's do that actually. So actually, raising a function to a power, well, isn't it just if you define g of x to be x to the n, and if you are getting g of h of x, well, that's just h of x to the n, right? Yes? So we can just define this to be some g of h of x. And so, as you might recall, to get the derivative of this, you just had to get the derivative of the function times the derivative of the inner function. And so in this case, well, we know that g of h of x, so we can just say that h of x is our u, right? And so d of u over d of x, well, that's just h prime of x, right? And then our g of h of x, well, we define it to be this. And so, as we said before, if this is just u, we're not worried about what its derivative is. We just can substitute it for u. So u to the n, well, let's just use the power rule. And so that's just n times u to the n minus 1, but we know that u is just h of x. And so this is exactly what the general power rule is. It's n times h of x to the n minus 1 times the derivative, that looks more like an h, it's supposed to be an n, times h prime of x. And this is our general power rule, derived from the original power rule and from the chain rule.